Jupiter, the largest planet in our solar system, emerges ahead like a world from another age. Its immense presence gradually filling your view as your vessel glides across the final 1,000,000 kilometers of space. The bands of color stretch across a disk so vast that Earth could disappear into the smallest of its storms without disturbing the clouds around it. You have been given something remarkable tonight, an imaginary vessel capable of descending through every layer of this world, technology that exists only in the space between curiosity and dreams. The journey ahead will carry you from the cloud tops all the way to the compressed core at the center of this enormous planet. The planet grows larger with each passing hour of approach, the disk expanding until it begins to dominate everything you can see through the forward observation ports. What appeared as a bright point among the stars when you departed Earth's orbit has become a world unto itself, a presence that fills the darkness ahead with color and motion. The bands of cloud wrap around the entire planet in horizontal stripes that never break or interrupt their endless circling of the globe. This is where your descent will begin, into an atmosphere so deep that no surface waits at the bottom, only increasingly dense gas extending all the way down. You are listening to the Drowsy Astronaut, and tonight we travel together into the heart of Jupiter, the king of planets in our small corner of the cosmos. This is a slow journey meant for late nights, when curiosity and rest can share the same quiet space without either demanding too much attention. If you enjoy these quiet journeys through the cosmos, feel free to share where you're listening from tonight in the comments below. A like or subscription is always appreciated, and for those who want to go a little deeper, memberships help support the channel and unlock even more long-form explorations of space and science. Tonight's journey is one I've been looking forward to sharing. It's a story filled with remarkable landscapes, hidden forces, and perspectives that never fail to leave me in awe. So settle in, get comfortable, and let's begin our descent. The scale of Jupiter challenges any easy comparison to things you might know from ordinary experience. The planet containing more mass than all other planets in the solar system combined. Over 1,300 Earths could fit within its volume if you could somehow pack them together inside this enormous sphere of gas and liquid, and whatever waits at the core. The diameter stretches roughly 140,000 kilometers, from one edge to the other, a distance that would take light nearly half a second to cross. Your approach brings you towards something genuinely vast, a world that almost became a star when the solar system was forming 4.5 billion years ago. The colors visible across Jupiter's disk range from white to cream to orange to brown, arranged in those horizontal bands that define the planet's appearance from any distance. The brighter bands, called zones, consist of clouds rising higher in the atmosphere, where temperatures drop low enough for ammonia to freeze into white ice crystals. The darker bands, called belts, represent regions where the atmosphere descends, warmer temperatures creating the darker colors that contrast with the bright zones above them. This pattern of rising and sinking creates the banded structure visible from millions of kilometers away, a pattern that has persisted for as long as humans have turned telescopes toward this distant world. The planet rotates beneath your approaching vessel with a speed that seems almost impossible for something so large, completing a full turn in just under 10 Earth hours. This rapid rotation creates the slightly flattened shape visible even from this distance, the equator bulging outward while the poles compress under the centrifugal force of the spin. The same rotation drives the powerful winds that separate the bands from each other, jet streams flowing in alternating directions around the planet at hundreds of kilometers per hour. Your descent will carry you through these winds, through the layers they shape, all the way to the still and compressed heart, where rotation has no meaning. The great red spot rotates into view as Jupiter turns, a storm larger than Earth that has been raging continuously for at least 400 years since humans first observed it through early telescopes. The spot appears as an oval of deep orange-red in the southern hemisphere, clouds rising higher than the surrounding atmosphere and catching sunlight at angles that create the distinctive color. Winds at the edges of this storm reach speeds exceeding 400 kilometers per hour, circling the high-pressure center in a counterclockwise rotation that has never stopped in all the centuries of observation. This storm alone could swallow our entire home planet, with room to spare around the edges. The persistence of the Great Red Spot speaks to the stability of Jupiter's atmospheric patterns, features that last for centuries rather than the days or weeks that storms persist on Earth. The energy driving this storm comes from Jupiter's internal heat, the planet radiating more energy into space than it receives from the distant Sun through processes of slow gravitational compression. This internal heat drives the convection that powers the winds, that separates the bands, that maintains the patterns visible across the planet's enormous face. The world ahead of you is not a static thing, but a dynamic system, constantly churning and mixing, even as its largest features appear stable over human timescales. Your vessel continues closing the distance, the planet growing until its edges begin disappearing beyond the frame of your forward view, the curvature of this enormous world barely perceptible at its scale. The approach angle carries you toward the equatorial region where the bands are widest and the rotation is fastest, the entry point for your descent through the atmosphere. No landing awaits at the end of this journey. Jupiter has no surface to land on, no solid ground beneath the clouds. Only gas that becomes liquid, that becomes something stranger still, as pressure increases with depth. The destination is the center itself, a point defined by geometry rather than any physical feature you could stand upon. The colors become more vivid as distance decreases, the subtle variations within each band revealing themselves to closer observation than was possible from farther away. Within the broad stripes visible from millions of kilometers out, smaller structures appear, swirls and eddies where different flows interact. Oval storms smaller than the Great Red Spot, but still enormous by any earthly standard, waves and ripples in the cloud tops that indicate the dynamics hidden beneath. Each of these features represents something happening in the atmosphere, energy being transferred, material being circulated, the planet living through processes that never rest. Your descent will carry you through all of this. The transition from approach to descent happens gradually. Your vessel beginning to feel the first traces of atmospheric resistance as Jupiter's outer gases extend far beyond the visible cloud tops into space itself. These outermost reaches are nearly vacuum by any ordinary standard. just traces of hydrogen and helium that mark the boundary between where Jupiter ends and interplanetary space begins. The boundary is not sharp but gradual, a slow increase in density that your instruments detect before your senses could perceive any change in the environment around you. You are entering the atmosphere of another world, beginning a descent that will take you deeper than any human has ever traveled into any planet. The stars visible through your rear observation ports remain unchanged. The universe behind you still showing the same patterns that guided navigation during the long cruise from Earth's orbit to this destination. Ahead, the planet has become everything. The dark sky replaced by the illuminated disk of Jupiter, extending beyond the edges of what your eyes can take in at once. The sunlight that reaches this distance from the sun is weaker than what Earth receives, perhaps 4% as intense, yet still bright enough to illuminate the cloud tops clearly against the darkness of space. This light will fade as you descend, the atmosphere above you eventually blocking the sun completely. But for now, the clouds glow with reflected daylight. The winds at the cloud tops will welcome you into the atmosphere, or at least acknowledge your presence, as they have acknowledged every molecule that has ever descended or risen through these gaseous layers. The jet streams flowing eastward and westward in alternating bands will try to carry your vessel along their paths. Forces that your propulsion must counter to maintain the descent trajectory toward the deep interior. The planet does not particularly notice your arrival. Jupiter is too vast and too ancient to care about the passage of any single object through its eternal storms. Yet you are here, approaching the entry point, ready to begin the journey that will carry you all the way to the center. The equatorial zone directly ahead glows brightest among all the bands, high-altitude ammonia ice, reflecting sunlight more efficiently than the colored materials in the belts to either side. This region will be your entry point, your vessel angling downward through the upper atmosphere, toward the cloud deck that forms the first substantial layer in Jupiter's atmospheric structure. The descent trajectory has been calculated for this approach. The angle of entry planned to carry you through the various layers at a pace that allows observation of each level before the next begins. The planet waits below, ready to receive you into its vast interior, where no human vessel has ever traveled. The final approach phase brings your vessel into contact with the outermost gases, resistance building slowly as the atmosphere thickens around you in the transition from space to air. The word air barely applies here. This is hydrogen and helium, not the nitrogen and oxygen mixture that fills Earth's atmosphere. A different chemistry entirely, in a different kind of world. Yet the physics remain the same. Gas molecules colliding with your vessel's exterior, slowing your approach through friction that will continue building as you descend into denser and denser regions below. The atmosphere welcomes you through resistance, the first touch of Jupiter against the craft that carries you into its depths. The color of space changes as your descent begins in earnest, the black giving way to a faint glow as the atmosphere thickens enough to scatter some of the sunlight penetrating from above. This glow is subtle at first, almost imperceptible, the darkness merely becoming slightly less absolute rather than actually becoming bright by any reasonable standard. Yet the change marks a transition, the crossing of an invisible line between the emptiness of space and the substance of this world's extended atmosphere. You are inside Jupiter now, Technically speaking, even though the gases surrounding you remain thinner than any vacuum humans have ever created in laboratories on Earth. The descent carries you through the upper thermosphere, where temperatures paradoxically rise despite the increasing distance from the sun. Solar radiation and charged particles heating the sparse gases to hundreds of degrees. This heat does not threaten your vessel. The gases are too thin to transfer significant energy, despite their high temperatures. The same principle that allows spacecraft to orbit Earth in the outer atmosphere without burning up. The warmth is a property of the few molecules present, rather than a feature of the environment as a whole. A physicist's distinction that matters greatly for understanding what is happening around you. Deeper layers will bring different temperatures through different mechanisms. The view behind you now shows the curve of Jupiter's limb against the darkness of space, the edge of the planet visible where the atmosphere thins to transparency and the stars shine through unchanged. You are descending into this world, traveling deeper with each passing moment. The cloud tops still far below, but closer than they were when your approach began. The layers ahead will bring cold and pressure, chemistry you could not breathe, and conditions you could not survive unprotected. Yet your imaginary vessel carries you onward toward the destination at the center. The journey has begun, the first layer penetrated, the descent into Jupiter truly underway as the stars fade behind you and the clouds wait below. The transition from space to atmosphere continues as your vessel descends through regions where the gases gradually thicken from near vacuum towards something more substantial that resists your passage with increasing force. The thermosphere has given way to the stratosphere, temperatures dropping as you move lower through layers that absorb less of the solar radiation that heated the uppermost reaches. The gases around you remain too thin to see. No clouds or haze visible at this altitude. Only the gradual brightening of scattered sunlight, indicating that substance surrounds you now, rather than the emptiness of space. The descent carries you downward through hundreds of kilometers of clear atmosphere toward the cloud tops that still wait far below. The composition of the atmosphere surrounding your vessel consists almost entirely of hydrogen, roughly 90% of the molecules being this simplest of all elements, with its single proton and single electron. Helium contributes most of the remaining 10%, the same gas that fills party balloons on Earth, existing here as a major component of a giant planet's atmosphere. Trace amounts of other compounds add variety to this simple mixture: methane, ammonia, water vapor, and more complex molecules in quantities too small to significantly affect the overall composition. This hydrogen-helium atmosphere extends without interruption all the way down through the planet, becoming liquid and eventually metallic, but never encountering any other substance in bulk. The temperature continues falling as you descend, the stratosphere giving way to the troposphere, where weather happens and clouds form from the condensation of various gases at their respective freezing points. The cold here exceeds anything experienced in natural environments on Earth, dropping below -100 degrees Celsius and continuing downward as you approach the altitude where the first clouds will form. Your vessel's exterior frosts over with frozen hydrogen compounds sublimating directly from the gases around you. Delicate crystals that form and reform as conditions change with altitude. The cold is real and intense, yet it represents only the beginning of what temperature extremes this journey will encounter. The first visible features of Jupiter's atmosphere begin appearing in the distance below, the tops of clouds that have seemed so close from space, now revealing the vast depth of clear atmosphere that separates them from the levels through which you are currently passing. These cloud tops catch the sunlight that penetrates to their altitude, reflecting it back towards space and toward your approaching vessel. The first substantial objects you have encountered since leaving the void of interplanetary space behind. The clouds are not smooth but textured, peaks and valleys in the atmospheric structure, visible as variations in brightness across the approaching surface. Your descent will carry you through these clouds and into the hidden layers beneath. The atmosphere has become thick enough now that flight dynamics begin to apply. Your vessel no longer falling freely through vacuum, but pushing through gas that exerts significant force against your passage. The resistance slows your descent, requiring thrust to maintain the trajectory that will carry you through the cloud layers rather than bouncing off them like a stone skipping across water. The transition from spacecraft to something more like an aircraft happens gradually, the physics of your motion changing as the environment around you becomes more substantial with each kilometer of descent. The planet is welcoming you into its atmosphere through the universal language of resistance and pressure. The cloud tops approach as your descent continues, the textured surface resolving into greater detail with each passing minute of observation and approach. What appeared smooth from space reveals itself as turbulent, constantly moving, shaped by winds that flow at hundreds of kilometers per hour in patterns established billions of years ago when the planet first formed. The clouds do not simply exist, they participate in a dynamic system of circulation that never stops, driven by the planet's internal heat and rapid rotation in perpetual motion. You are approaching not a static surface, but a living system of weather that extends around the entire planet. The distinction between the bright zones and darker belts becomes clearer as you near the cloud tops, the contrast representing differences in altitude rather than simply differences in color or composition. The zones rise higher, their clouds reaching altitudes where temperatures drop low enough for ammonia to freeze into the white ice crystals that give them their bright appearance. The belts sink lower, warmer temperatures preventing the ammonia from freezing and allowing other compounds to dominate the visible appearance with their orange and brown tones. This vertical separation creates the horizontal banding that defines Jupiter's appearance from any distance, a pattern written in the atmosphere by rising and sinking gas. The sunlight around you has dimmed noticeably since you left the outer atmosphere, the accumulating gas above filtering out some of the solar radiation before it can reach your current depth. The sky no longer appears black, but has taken on a subtle color, scattered light creating a glow that surrounds you in all directions rather than coming only from the direction of the distant sun. This diffuse illumination will continue changing character as you descend, the sunlight eventually fading to nothing in the deep atmosphere where your vessel's lights will provide the only illumination. For now, the glow provides enough light to observe the approaching cloud tops in their full complexity. The first ammonia ice clouds are close enough now to fill most of your forward view. The surface you're approaching no longer distant, but immediate. The entry into the cloud deck only moments away. These clouds represent the boundary between the clear atmosphere above and the layered structure below, the first of several distinct cloud decks you will pass through during your descent toward the deep interior. The ammonia ice crystals that compose these clouds form where temperatures drop to approximately minus 145 degrees Celsius, cold enough for this pungent gas to freeze directly from vapor into solid ice. Your vessel will pass through these clouds, through the ice crystals themselves, continuing downward toward layers where different chemistries dominate. The entry into the ammonia cloud deck happens without any dramatic transition, the clear atmosphere simply giving way to increasing haze as ice crystals begin appearing around your vessel in concentrations that grow with each kilometer of descent. Visibility decreases gradually, the distant features that were visible moments ago now obscured by the accumulating ice particles that scatter and absorb the light passing through them. The color around you shifts toward white and cream, the characteristic tones of ammonia ice dominating the visual experience as you descend through the first substantial cloud layer of this enormous planet. You are inside the clouds of Jupiter now, surrounded by frozen ammonia in a world no human has ever directly observed. The ice crystals streaming past your observation ports reveal the winds at this altitude, the flow of atmosphere-carrying material horizontally at speeds that your instruments measure in hundreds of kilometers per hour. These winds represent the visible expression of the jet streams that separate Jupiter's bands from each other. Atmospheric currents that have flowed continuously for longer than Earth has hosted complex life. The clouds are not still, but moving, constantly in motion, participating in the planetary circulation that distributes heat and energy from the deep interior toward the cold upper atmosphere and space beyond. Your descent carries you through this motion, briefly participating in flows that have been underway for billions of years. The ammonia ice clouds extend for roughly 50 kilometers of vertical descent, a layer thick enough to substantially reduce the sunlight penetrating from above, but thin enough to transit in reasonable time as your vessel continues its journey toward the center. The cloud deck is not uniform, but varies in density, regions of thicker accumulation alternating with thinner areas, where glimpses of what lies below occasionally appear before closing again. The structure reflects the dynamics creating these clouds. Convective cells and wave patterns organizing the ice crystals into formations that would be beautiful if you could observe them from outside rather than from within. The experience is one of immersion rather than observation, being inside rather than watching. The temperature at this level hovers around minus 145 degrees Celsius, cold enough to freeze ammonia, but maintained at this value by the processes of condensation and evaporation that form and dissipate the cloud layer. Energy is released when ammonia vapor freezes into ice crystals, energy that moderates the temperature change with altitude and creates the relatively stable conditions that characterize this cloud deck. The physics are the same as those that govern cloud formation on Earth, but the chemistry is entirely different. Ammonia replacing water as the condensing substance in this alien atmosphere. The familiar and the foreign blend together in this environment. The pressure at this altitude measures roughly half an Earth atmosphere, still comfortable enough that unprotected humans could theoretically survive the pressure itself, even though the temperature and composition would prove instantly fatal. This pressure represents the weight of all the atmosphere above this level, pressing down, a column of hydrogen and helium extending through the stratosphere and thermosphere all the way to the transition with interplanetary space. The pressure will continue building as you descend, doubling and redoubling with depth until it reaches values that have no comparison in any natural environment on Earth. The half atmosphere at this level represents only the beginning. The journey through the ammonia cloud deck continues as your vessel maintains its descent trajectory, passing through the densest regions of ice crystal concentration toward the lower boundary where this cloud layer gives way to clear atmosphere again. The transition will bring another layer into view, clouds of different composition at different temperatures, forming the second major deck in Jupiter's atmospheric structure. The ammonia ice will thin and eventually disappear, replaced by chemistry that creates the orange and brown colors visible in Jupiter's belts from space. Your descent carries you toward this transition, toward the next layer, toward the deeper regions, where pressure and temperature continue their relentless increase. The ammonia ice clouds thin gradually around your vessel as you descend through the lower portions of this first major cloud layer, visibility improving as the concentration of ice crystals decreases with depth. The white and cream colors that surrounded you during the densest portions of the cloud deck begin giving way to different tones, hints of the layer below appearing through the remaining haze like landscape emerging through morning fog. The transition happens over kilometers of descent, not suddenly, but progressively. The ammonia giving way to clear atmosphere that will extend for another several thousand meters before the next cloud deck begins. You are passing through the boundary between two distinct regions of Jupiter's layered atmosphere. The clear atmosphere below the ammonia clouds provides your first opportunity since entering the planet to see significant distance in any direction, the haze above you now rather than around you. Looking upward reveals the cloud layer you just descended through as a bright ceiling catching the sunlight, still penetrating from above. The ice crystals reflecting light back toward space, while allowing some portion to continue downward toward your current position. The illumination here remains substantial, dimmed by the passage through the ammonia clouds, but still bright enough to observe the environment without artificial assistance. The journey downward continues through this clear zone, toward whatever waits below. The temperature has risen slightly since leaving the coldest regions of the ammonia cloud deck, the atmosphere warming as you descend into regions where pressure compresses the gas more tightly. This warming might seem counterintuitive. Moving deeper into a planet typically brings colder conditions in everyday experience. But Jupiter operates differently. The compression of gas, releasing heat that accumulates with death. The temperature at this level has risen to approximately -80 degrees Celsius, still bitterly cold by any human standard, but noticeably warmer than the ammonia cloud tops above. This warming trend will continue throughout your descent. The next cloud layer becomes visible below as you descend through the clear zone, a deck of different character than the white ammonia ice that surrounded you during the previous portion of your journey. These clouds show colors in the brown and orange range, the distinctive tones of ammonium hydrosulfide, a compound that forms when ammonia and hydrogen sulfide combine at the temperatures and pressures found at this depth. The chemistry is different, the appearance is different, and the experience of descending through this layer will differ from what you encountered in the ammonia clouds above. Jupiter's atmosphere reveals its complexity through these layered structures. The entry into the ammonium hydrosulfide cloud deck brings the expected change in visual environment, the browns and oranges replacing the whites and creams that characterize the layer above. The clouds here form roughly 2 Earth atmospheres of pressure, the weight of all the atmosphere above pressing down with twice the force that sea level air exerts on surfaces back on your home world. The pressure is still comfortable enough not to threaten your vessel, but it represents a meaningful increase from the near vacuum of space, where this journey began. Each layer brings greater pressure. Each kilometer of descent adds weight. The temperature at this level has risen to approximately -80 degrees Celsius, warm enough that ammonia can no longer freeze, but cold enough that the ammonium hydrosulfide compounds can condense from the vapor phase into the particles that form these distinctively colored clouds. The chemistry requires both ammonia and hydrogen sulfide in the atmosphere, the two gases combining, when conditions permit, to create the third compound that makes these clouds possible. The process is continuous, new particles forming constantly as gases circulate through the temperature range. Where condensation occurs, old particles evaporating as they sink into warmer regions below. The colors around you shift as you descend through different concentrations within this cloud layer. Deeper oranges and browns indicating regions of greater particle density, while lighter tones mark areas where the clouds thin slightly. The variation reflects the dynamics of this level, convective motion carrying material up and down through the cloud deck, organizing particles into patterns that a patient observer might eventually recognize as recurring features. The layer is alive with motion, like the ammonia clouds above, participating in the same planetary circulation that moves heat and material throughout the atmosphere. The visibility within this cloud layer remains limited, the particles absorbing and scattering light in ways that restrict how far you can see in any direction through the orange-brown haze surrounding your vessel. The experience differs from the ammonia clouds primarily in color. The physical sensation of being suspended in haze, unable to see distant features, characterizes both layers equally. The journey through this deck will take time, the layer thick enough to require sustained descent before emerging into whatever clear zone or different cloud structure waits below. Patience is required, patience and trust in the vessel carrying you deeper. Looking upward from within this layer reveals the ammonia clouds above as a brighter region through the thinning upper portions of the ammonium hydrosulfide deck. The white of frozen ammonia visible through the orange-brown haze when conditions permit glimpses in that direction. The two layers are distinct enough that the boundary between them can be perceived from either side. Different chemistries creating different visual environments stacked atop each other in the vertical structure of the atmosphere. Below, another boundary waits. The transition from this layer to the water clouds that form the deepest deck of condensation in Jupiter's atmosphere. The pressure continues building as your descent progresses through the ammonium hydrosulfide clouds, the weight of atmosphere above growing with each kilometer of downward travel through these colored gases. The measurement has reached several Earth atmospheres now, significant enough that unprotected humans would begin experiencing discomfort, even though the pressure itself remains well within survivable ranges. The chemistry and temperature would remain fatal. Regardless, no amount of pressure tolerance would help you survive exposure to -80-degree ammonia sulfide atmosphere without protection. Your vessel shields you from an environment that would be lethal in multiple ways. simultaneously. The winds at this level differ from those in the ammonia clouds above. The jet streams organizing atmospheric flow in patterns that shift with altitude throughout Jupiter's atmospheric structure. The particles streaming past your observation ports indicate motion at speeds that remain impressive by earthly standards, though perhaps slightly slower than the most extreme velocities encountered near the cloud tops. The planet's rapid rotation drives these winds, the Coriolis effect organizing flow into the banded pattern visible from space, while convection, driven by internal heat, provides the energy that maintains the motion continuously. The winds have been blowing here since the planet formed. The transition from cloud to clear atmosphere begins appearing below as you approach the lower boundary of the ammonium hydrosulfide layer. The orange-brown haze thinning to reveal glimpses of what lies beneath. The view opens up gradually, visibility increasing with each 100 meters of descent as the particle concentration decreases, and the light scattering that limited your vision becomes less pronounced. Another clear zone approaches. The gap between this cloud deck and the water clouds that form the next and final condensation layer in your descent toward the deep interior. The layers stack like geological strata, each with its own character. The ammonium hydrosulfide clouds gave these regions of Jupiter their distinctive brown and orange appearance when viewed from space. The darker belts, representing areas where this layer is more visible through gaps in the ammonia clouds above. The zones and belts that stripe the planet result from this vertical separation of cloud types. The bright zones showing high ammonia clouds, while the dark belts reveal the colored layers beneath through thinner regions of the uppermost deck. The banded appearance that defines Jupiter from any distance represents a three-dimensional structure collapsed into a two-dimensional view by the perspective of remote observation. The clear atmosphere below the ammonium hydrosulfide clouds extends for several kilometers. Another transition zone between distinct cloud layers where your visibility temporarily improves before entering the next deck of condensation. The temperature continues rising, the pressure continues building, the environment becoming gradually more extreme with each stage of your descent toward the center of this enormous planet. The water clouds wait below, the deepest layer of condensation where familiar chemistry creates clouds of ice and liquid water droplets. In an otherwise entirely alien environment, the journey continues downward. The clear zone between the ammonium hydrosulfide clouds and the water clouds below provides a brief respite from the reduced visibility that characterized your passage through the upper cloud decks. The atmosphere transparent enough to see significant distances again. The view above shows the orange-brown layer you just descended through, now visible as a ceiling of color, catching what light penetrates from the still brighter ammonia clouds far overhead. Below, another cloud deck approaches, this one different in character from everything you have encountered so far on your journey into Jupiter's atmosphere. The water clouds wait ahead, the deepest layer of condensation in this enormous world. The presence of water in Jupiter's atmosphere represents something familiar in an otherwise alien environment, the same molecule that fills Earth's oceans, existing here as ice crystals and liquid droplets in clouds deep within a gas giant. The chemistry is identical. Two hydrogen atoms bonded to one oxygen atom in the configuration that life on Earth depends upon for its existence and operation. Water is not the dominant substance here, as it is in Earth's oceans. It exists as a trace component in the hydrogen-helium atmosphere, condensing into clouds only where temperature and pressure conditions permit. Yet, its presence connects this alien world to the familiar chemistry of your home planet. The temperature at the water cloud level has risen substantially from the bitter cold of the ammonia and ammonium hydrosulfide layers above, approaching the freezing point of water, where ice crystals can form and persist in the atmospheric conditions found here. The warming continues with depth, the compression of gas releasing heat that accumulates as you descend through each successive layer of the atmosphere. The pressure at this level reaches approximately 5 Earth atmospheres, 5 times the weight that air exerts on surfaces at sea level back on your home world. The environment becomes more extreme with each phase of your journey. The water clouds become visible below as you approach their upper boundary, appearing somewhat darker than the layers above, due to the greater depth from which light must travel to reach your current position. The sunlight illuminating this level has passed through thousands of kilometers of atmosphere, through 2 cloud decks that absorbed and scattered some portion of its energy before it could penetrate to the depths where water condenses. The illumination is dimmer here than it was at the ammonia cloud tops. The colors shifted toward orange and red as the shorter wavelengths were scattered away by the long passage through the atmospheric layers above. The entry into the water cloud deck brings a visual environment that would seem almost familiar to anyone who has flown through Earth's clouds. The ice crystals and water droplets forming a grey-white haze that resembles terrestrial weather systems in appearance if not in composition or context. The clouds here form through the same physical processes that create clouds on Earth. Water vapor cooling to the point where it condenses into liquid droplets or freezes into ice crystals, depending on exact temperature conditions. The familiar behavior in an unfamiliar setting creates a strange resonance, home appearing within the depths of an alien giant. The lightning that flashes occasionally within these water clouds provides another connection to familiar weather phenomena. Electrical discharges building up and releasing through processes similar to those that create thunderstorms on Earth. Jupiter's lightning differs in scale. The bolts can be thousands of times more powerful than their earthly counterparts. The energy discharge proportional to the size of the planet where they occur. The flashes appear in your peripheral vision, illuminating regions of cloud momentarily before fading back to the dim ambient lighting that characterizes this deep level. The thunder would be audible if your vessel were equipped to detect it, sound waves propagating through the dense atmosphere. The temperature within the water cloud layer hovers around the freezing point of water, the boundary between ice and liquid that determines which phase dominates in different regions of this condensation deck. Some portions of the cloud consist primarily of ice crystals, frozen water caught in conditions just cold enough to maintain the solid phase against the warming influence of compression. Other regions contain liquid droplets, tiny spheres of water suspended in the hydrogen atmosphere, like rain that has not yet fallen. The boundary between these regions shifts constantly as the dynamic atmosphere circulates material through different temperature conditions. The view through the water clouds differs from the layers above in subtle ways. The character of the scattering and absorption different for water than for ammonia or ammonium hydrosulfide particles. The light reaching your vessel has traveled through many kilometers of water cloud, filtered by interactions with familiar molecules in an unfamiliar context. The color has shifted toward warmer tones, the blues and greens of the spectrum preferentially scattered away, while the reds and oranges penetrate more effectively to these depths. The illumination resembles a perpetual sunset without a sun, warm light suffusing the clouds around you from above. The pressure at this depth has increased substantially from the upper atmosphere, the accumulating weight of all the gas above pressing down with force that would be uncomfortable even for the protective capability of your vessel. The measurement approaches 10 Earth atmospheres, 10 times the pressure that air exerts on surfaces at sea level, approaching the limits that unassisted humans could survive even briefly. The deeper regions ahead will bring pressures that exceed any natural environment on Earth by large margins, crushing forces that only specialized equipment can withstand. Your vessel was designed for this journey. The water cloud layer represents the final condensation deck in Jupiter's atmosphere, the last level where any substance freezes or liquefies into visible particles that form clouds and hazes. Below this layer, the atmosphere becomes clear hydrogen and helium gas, without any condensation to create visible structure until the gradual transition from gas to liquid occurs at depths still far below your current position. The journey through the water clouds will eventually give way to a long descent through transparent atmosphere, visibility improving even as the light from above continues fading toward eventual darkness. The clouds will end. The lower boundary of the water clouds approaches as your descent continues, the concentration of water droplets and ice crystals thinning until eventually the atmosphere becomes clear enough to see significant distances in the direction you are traveling. The transition zone marks the end of Jupiter's cloud structure, the completion of your passage through the 3 distinct decks that create the planet's visible appearance when observed from space or approaching spacecraft. Below the water clouds, the atmosphere extends without visible features for thousands of kilometers, clear gas that will eventually transform into liquid, and then into something stranger still. The journey continues into regions where no clouds form. The experience of leaving the cloud layers behind creates a shift in the character of your descent, the hazy environments of ammonia and ammonium hydrosulfide, and water giving way to transparency that allows you to see how far you have come and how far you still must travel. Looking upward reveals all 3 cloud decks now visible as distinct layers above you, the water clouds nearest, then the orange-brown ammonium hydrosulfide layer, then the distant bright ceiling of ammonia ice, catching the sunlight that penetrates to its altitude. The structure of Jupiter's atmosphere reveals itself through your position within it, layers stacked upon layers extending upward toward the cold of space. The clear atmosphere below the water clouds extends around your vessel in all directions, the first truly transparent environment you have encountered since the brief clear zone between the upper cloud decks, far above your current position. The visibility is remarkable after the extended passage through 3 distinct layers of haze and clouds, allowing you to observe the structure of the atmosphere over distances measured in kilometers rather than meters. The view above shows the water cloud layer as a ceiling of grey-white, the light filtering through these clouds, providing the dim illumination that characterizes this depth. Below, the clear atmosphere extends without visible features toward depths where the transformation from gas to liquid will eventually occur. The temperature at this level has risen above the freezing point of water, warm enough that no condensation can occur, and the atmosphere remains free of any particles that might create haze or reduce visibility. The warming continues with depth, compression heating the gas as pressure increases with each kilometer of descent through the clear region. The measurement now shows temperatures that would feel merely cold rather than lethally frigid, perhaps minus 20 degrees Celsius, though exposure to the hydrogen atmosphere would remain instantly fatal regardless of the temperature. The environment becomes gradually more survivable in some ways, while remaining completely hostile in others. The pressure continues its relentless increase, the weight of all the atmosphere above pressing down with force that has reached 10 Earth atmospheres and continues building toward values that exceed anything naturally encountered on your home world. This pressure represents only the beginning of what awaits in the deep interior. The regions ahead will bring pressures of hundreds, thousands, and eventually millions of atmospheres as you approach the core at the center of this enormous planet. The clear atmosphere around you gives no visual indication of this building pressure, the gas appearing unchanged, despite the increasing density that your instruments measure with each kilometer of descent. The light from above has dimmed substantially since you entered the water cloud layer, and the reduction continues as you descend through the clear atmosphere toward deeper regions where sunlight cannot penetrate. The illumination remains sufficient for observation without artificial assistance at your current depth. But the quality has changed. The color shifted toward orange and red, the intensity reduced to something resembling twilight rather than full daylight. The sun is no longer a distinct source in any direction, but rather a general glow filtering down through the thousands of kilometers of atmosphere that now separate you from the boundary with space far above. The descent through the clear atmosphere continues for what seems like an extended time, the lack of visible features making progress difficult to perceive, except through the changing readings on instruments that track depth, pressure, and temperature. The environment appears static, even as you travel through it, at descent speeds that would seem rapid in any terrestrial context. The uniformity of clear hydrogen atmosphere extending without variation through kilometers of vertical distance. The mind begins adapting to this featureless passage, finding its own rhythm in the unchanging environment as the journey continues toward whatever transformation awaits below. Looking in any horizontal direction reveals atmosphere that extends beyond your ability to see any boundary or feature. The clear gas surrounding you in what appears to be infinite extent in directions perpendicular to your descent. The curvature of the planet is far too gentle to perceive at any scale you could observe. Jupiter so large that its surface appears flat from any vantage point within the atmosphere. You are suspended in a sphere of clear gas that seems to extend forever. Only the fading light from above and the steady descent readings giving any indication of progress through this vast and featureless region. The experience is one of traveling without moving, motion without landmarks. The temperature continues rising as compression heats the atmosphere with increasing depth. The readings now showing values above the freezing point of water and climbing toward room temperature as the descent progresses. The warmth might seem welcoming after the bitter cold of the upper cloud layers, but the context differs so completely that the comparison barely holds meaning. This is not the warmth of a comfortable room, but the heat of gas being squeezed by pressures that exceed any natural terrestrial environment. The warming trend will continue throughout your descent, eventually reaching temperatures that exceed the surface of the sun as you approach the core at the center. The pressure readings have climbed past 10 Earth atmospheres and continue building, the weight of atmosphere above accumulating with each kilometer of travel through the clear gas that surrounds your vessel. The density of the gas increases proportionally. The hydrogen molecules packed more closely together by the crushing force from above. Resistance to your vessel's passage, growing as the medium becomes more substantial with depth. The transition from gas to liquid that waits somewhere below will not happen suddenly, but gradually. The distinction between these states of matter becoming meaningless under the extreme conditions found in Jupiter's deep interior. The silence of this region impresses itself upon your consciousness. The absence of visible features, leaving only the quiet hum of your vessel and the unchanging view in all directions. The clouds are above you now, all three layers visible when you look upward through the clear atmosphere, toward the distant light, still filtering down from the sun. Below, the same clear atmosphere extends without feature, the transformation to liquid hydrogen still thousands of kilometers distant, even at the pace of your continuous descent. The journey through this featureless region continues, meter by meter, kilometer by kilometer, the depth increasing without visible acknowledgement from the environment around you. The quality of light continues its gradual transformation as you descend, the dim illumination taking on increasingly warm tones as the last traces of blue light are scattered away by the accumulating atmosphere above. The experience resembles a sunset that extends for hours rather than minutes, the warm colors deepening gradually, without any horizon to mark the sun's position or progress. The light will eventually fade to nothing as you descend beyond the depth that any solar radiation can penetrate, your vessel's lights becoming the only illumination in the darkness of Jupiter's interior. That transition approaches, but has not yet arrived. The instrument readings tell the story of your descent in numbers that have no visual confirmation in the featureless atmosphere around you. Depth increasing, pressure building, temperature rising, all the measurements moving in the directions that physics predicts, without any visible change in the clear gas through which you travel. The descent continues by instruments alone. Trust in the calculations that plan this trajectory required in the absence of landmarks that might confirm progress through more immediate observation. The journey has become an act of faith in physics, belief in the laws that govern this environment even when your eyes cannot confirm what your instruments report. The first hints of change appear not in the visual environment, but in the behavior of your vessel, the resistance to movement increasing noticeably as the gas around you becomes denser with depth. The hydrogen is transitioning, not suddenly, but gradually, the molecules packing closer together under the increasing pressure, until the distinction between gas and liquid begins losing meaning. This supercritical transition represents one of the strangest phenomena you will encounter on this journey. The familiar boundaries between states of matter dissolving under conditions that exist nowhere on Earth's surface. You are entering a realm where common understanding of how substances behave no longer fully applies. The light from above continues its gradual fade as your vessel descends through the deepening atmosphere. The solar illumination that has accompanied your journey since entering Jupiter, now beginning its final diminishment toward complete darkness. The transition happens slowly, the dim orange glow becoming dimmer still with each kilometer of descent. The last photons from the distant sun, scattered and absorbed by the thousands of kilometers of atmosphere now above you. The view through your observation ports takes on a character unlike anything experienced on worlds with solid surfaces. Twilight without a horizon, darkness approaching from all directions simultaneously. The deep interior of Jupiter is swallowing the last light. The clear atmosphere around you remains transparent, allowing you to see as far as light will carry in any direction. But that distance shrinks as the illumination continues fading from the levels that characterize the upper portions of the clear region. The instruments measuring light intensity show the decline in numbers that your eyes confirm through direct observation. The environment darkening toward values that will eventually reach zero as you descend beyond any depth that sunlight can penetrate. The journey has carried you past the boundary where natural illumination ends, and only artificial sources can provide visibility. Your vessel's lights begin contributing meaningfully to what you can see. The temperature continues rising as compression heats the atmosphere, the readings now showing values that approach and then exceed the warmth of a comfortable room on Earth. The heat has nothing to do with proximity to any energy source. The sun is actually farther away now than when you were in space, its radiation blocked by the atmosphere rather than warming you directly. The warmth comes from compression, the work done by gravity pressing down on the gas from above, energy that has no escape route except the slow conduction and convection that carries it upward over timescales far longer than your descent. You are descending into heat that has been accumulating since the planet formed. The pressure has reached values that exceed any natural environment on Earth by large margins. The readings showing tens of atmospheres pressing against your vessel from all directions. The gas has become dense enough that the sensation of resistance to movement has become noticeable even through the protective structure of your craft. The medium through which you travel, pushing back against your passage with increasing force. The distinction between this dense gas and a liquid becomes difficult to perceive through any direct observation. The transition zone approaching where scientists describe the hydrogen as supercritical. Neither gas nor liquid in the conventional sense, but something in between. The fading light from above takes on its final warm tones as the last remnants of solar illumination filter down through the immense column of atmosphere, separating you from the distant sun. The color has shifted entirely into the orange and red portion of the spectrum, the shorter wavelengths having been scattered away completely by the passage through the upper layers. The light itself changed by its journey through the planet's atmosphere. The experience resembles the final moments of twilight, stretched across kilometers of descent, rather than the minutes that sunset takes on Earth. The darkness approaches with gentle inevitability. The silence of the descent deepens along with the darkness, the absence of visual reference enhancing the quiet that has characterized this portion of the journey since leaving the weather and motion of the cloud layers behind. No wind carries particles past your observation ports at this depth. The atmosphere is too deep, too still, too far from the energy sources that drive motion in the upper layers. The gas through which you travel merely exists, pressing inward from all directions with the weight of everything above, participating in the slow compression that extends all the way down to the core. The stillness is profound. The final transition to darkness happens without drama, the dim illumination simply fading below the threshold where your eyes can detect it. The world outside your observation ports becoming completely black, except where your vessel's lights create cones of visibility in the dense atmosphere. The darkness is not threatening, but simply complete. The natural condition of Jupiter's deep interior, where no sunlight has penetrated since the planet formed from the solar nebula over 4 billion years ago. You have descended beyond the reach of the sun, into regions that have never known natural illumination. The lights from your vessel reveal the atmosphere immediately surrounding you. The hydrogen gas, dense enough now that the beams scatter noticeably from the molecules they encounter, creating a slight haze in what was previously clear atmosphere. The effect resembles the way headlights illuminate fog on Earth, though the medium here is pure hydrogen rather than water droplets. The scattering produced by density alone, rather than by particles of different composition. The visibility extends for perhaps a few hundred meters in any direction, the light absorbed and scattered by the increasingly dense gas before it can travel farther. Your world has shrunk to a small illuminated sphere. The temperature readings continue their upward trend, the heat of compression now reaching temperatures that would be uncomfortable on Earth's surface, and continuing to rise toward values that will eventually exceed anything in everyday experience. The environment outside your vessel has become something that no unprotected human could survive for any reason. The pressure, the temperature, the lack of oxygen, the absence of light, all combining into conditions that only specialized equipment can withstand. Your imaginary vessel carries you through an environment that would be instantly lethal in multiple independent ways, protected from conditions that have no parallel in human experience. The pressure readings have reached hundreds of atmospheres, the weight of all the atmosphere above, pressing down with force that would crush most structures and compress most materials to significantly smaller volumes. The gas outside your observation ports is dense enough now that the distinction between it and a liquid has become essentially academic. The hydrogen molecules packed so closely together that the behavior of the medium resembles liquid in every meaningful way. You have entered what scientists call the supercritical region, where gas and liquid merge into a single phase without a distinct boundary between them. The transition has happened without any visible change. The descent continues through this dense medium, your vessel pushing against resistance that has grown substantially from the near vacuum of space where the journey began. The environment outside is hydrogen, still hydrogen, always hydrogen, but hydrogen in a state that exists nowhere on Earth's surface, compressed and heated into something that defies the simple categories of solid, liquid, and gas that describe matter in ordinary conditions. The journey carries you through physical states that human science has reproduced only in laboratories, using extreme equipment. Natural conditions on this giant planet that experiments struggle to create artificially. The depth readings continue accumulating, kilometers adding to the total that now extends from the cloud tops far above, down through the clear atmosphere and into this dense region where light no longer reaches. The numbers are impressive by any standard. Tens of thousands of kilometers from where you started, toward a core that lies still deeper in the planet's interior. The scale of Jupiter reveals itself through the time required to traverse its layers. The planet so large that even continuous descent at meaningful speeds requires extended periods to cross from atmosphere to core. You are approximately 1/3 of the way down. The hydrogen surrounding your vessel has become something that would be difficult to recognize as the lightest and simplest element if you encountered it in this form without context. The material so dense and warm that its behavior resembles a liquid rather than the thin gas that filled the upper atmosphere. The transition from gas to liquid happened without any visible boundary, without any moment you could point to as the instant when one phase ended and another began. The supercritical nature of this transition means that no such moment exists. The hydrogen simply became denser and denser until the distinction between gas and liquid lost all meaning. You are swimming through an ocean that was once a sky. The resistance to your vessel's movement has increased substantially, the dense medium pushing back against your passage with force that the propulsion systems must overcome to maintain the descent trajectory. The sensation resembles traveling through increasingly thick fluid, though the comparison barely captures the conditions outside your protective shell. Hydrogen compressed to densities that exceed any liquid you might encounter on Earth, heated to temperatures that continue rising toward values that will eventually exceed the surface of the sun. The environment has become genuinely exotic, conditions found nowhere in human experience outside of laboratory experiments. The darkness remains complete outside the illumination provided by your vessel. No natural light penetrating to this depth from the distant sun, whose radiation was absorbed and scattered by the tens of thousands of kilometers of atmosphere now above you. The only visibility you possess comes from artificial sources, the beams from your vessel's lights, illuminating the dense hydrogen for a few hundred meters before scattering away into the surrounding darkness. The world has shrunk to this small sphere of light, suspended in endless black, a bubble of visibility traveling through an ocean of compressed gas that extends in all directions without boundary or feature. The temperature readings continue their steady climb, the heat of compression now reaching values that would destroy exposed equipment and render any unprotected area uninhabitable by any standard of survivability. The numbers on your displays show temperatures in the hundreds of degrees Celsius, climbing toward values that will eventually exceed 1,000 degrees as you approach the deeper regions where metallic hydrogen forms. The heat has no external source. The planet's interior generates no light at these depths, the warmth coming entirely from the pressure of all the mass above, squeezing the hydrogen into progressively smaller volumes. Compression generates heat, and Jupiter has been compressing since it formed. The pressure has reached thousands of atmospheres, forces that would crush any ordinary structure to a fraction of its normal size and would destroy most materials through the sheer magnitude of the compressive stress. Your vessel was designed for exactly these conditions. Its imaginary engineering, capable of withstanding pressures that exceed anything found naturally on Earth by factors of hundreds. The dense hydrogen, pressing inward from all directions, exerts force that would be difficult to comprehend without instruments to measure it. The weight of a planet concentrated on the protective shell that separates you from an environment that would be instantly and comprehensively fatal. The hydrogen at this depth exists in what scientists call the supercritical state, a phase of matter that shares properties of both gas and liquid without fully belonging to either category. The molecules are packed closely together like those in a liquid, dense enough to provide significant resistance to movement through the medium. Yet the substance also fills whatever volume contains it, uniformly like a gas, without the distinct surface that characterizes liquids in everyday experience. The transition from gas to this state happened gradually, the boundary between phases disappearing under the extreme conditions found at this depth in Jupiter's interior. The descent continues through the supercritical hydrogen, your vessel moving steadily deeper into the planet's interior as the depth readings accumulate kilometers of progress toward the core that waits at the center. The conditions change gradually rather than suddenly. Temperature and pressure increasing continuously without any dramatic transitions to mark progress through different regimes. The journey has become a slow process of increasing extremity, each kilometer bringing slightly higher temperature, slightly greater pressure, the environment becoming more hostile by increments that accumulate into enormous differences from where the journey began. The view through your observation ports reveals only the dense hydrogen illuminated by your vessel's lights. The beams scattering through the medium in ways that create a slight haze, limiting visibility to distances of perhaps 100 meters in any direction. The darkness beyond this illuminated sphere is absolute. Not merely the darkness of night, but the complete absence of any natural light source in an environment that has never known illumination. The planet's interior exists in permanent darkness, has existed in darkness since Jupiter formed, will continue existing in darkness for as long as the planet persists. Your vessel brings the only light this region has ever seen. The next transition approaches somewhere below your current position, a change far more dramatic than the gradual compression of gas into supercritical fluid that has characterized the descent so far. At sufficient depth and pressure, hydrogen will undergo a transformation into a metallic state, the electrons freed from their atoms to flow like those in familiar metals, the substance becoming something that conducts electricity and behaves in ways that hydrogen never does under ordinary conditions. This metallic hydrogen layer extends for most of Jupiter's remaining interior, an ocean of liquid metal surrounding the compressed core at the very center. The anticipation of this transition accompanies the descent through the final portions of the molecular hydrogen region, the conditions building toward the threshold where the metallic transformation will occur. The pressure readings approach 1 million atmospheres, 1 million times the weight of air at sea level on Earth, the value at which scientists believe the metallic transition begins in Jupiter's interior. The temperature has risen to thousands of degrees, hot enough to glow visibly if anything were present to emit light at these wavelengths. The environment has exceeded any conditions found naturally on Earth's surface, entering a regime that exists only in the deep interiors of giant planets. The molecular hydrogen around your vessel begins showing the first signs of the approaching transition. Subtle changes in its properties that indicate the electron structure of the atoms is responding to the extreme pressure. The behavior shifts gradually, the hydrogen becoming more metallic in character as the conditions approach the threshold for complete transformation. The transition will not happen suddenly, like everything else in this descent. It will occur gradually over kilometers of depth, the molecular hydrogen giving way progressively to metallic hydrogen as pressure continues building past the threshold values. The experience of approaching this boundary carries a weight appropriate to its significance. The journey about to enter a region where matter behaves in ways that have no parallel in everyday human experience. Metallic hydrogen has been created in laboratories only in tiny quantities, for fractions of seconds, using diamond anvils that generate extreme pressures momentarily. Here, in Jupiter's interior, billions of cubic kilometers of this exotic material have existed continuously for 4.5 billion years, an ocean of liquid metal larger than any natural feature elsewhere in the solar system. You are approaching the boundary of the largest metallic ocean in existence. The transition into the metallic hydrogen layer happens gradually around your vessel. The molecular hydrogen that has surrounded you throughout the descent, beginning to exhibit the electrical conductivity that defines the metallic state. The change occurs through the freeing of electrons from their parent atoms. The extreme pressure forcing hydrogen molecules apart and allowing their electrons to flow freely through the material, like those in copper or iron. The substance around you has become a liquid metal, not through melting but through compression, the simplest element transformed into something entirely unlike its familiar gaseous form. You are now traveling through the largest ocean of any kind in the solar system. An ocean made of metal rather than water. The conditions at this depth exceed any natural environment found elsewhere in human experience. The pressure measuring in the millions of atmospheres, the temperature climbing past 5,000 degrees Celsius. The density of the metallic hydrogen approaches that of liquid iron, the lightest element compressed into something approaching the heaviest common metals, through nothing more than the weight of atmosphere above. The measurements have moved beyond any easy comparison to ordinary conditions. The numbers representing forces and temperatures that exist only in stellar interiors and the deep cores of giant planets. Your imaginary vessel continues protecting you from conditions that would destroy any actual material almost instantaneously, carrying you deeper into an environment that becomes more extreme with each kilometer. The metallic hydrogen glows faintly at these temperatures, the first natural illumination you have encountered since descending past the depth where sunlight could no longer penetrate from the distant surface. The glow is dim, far too dim to provide useful visibility for navigation or observation, but it represents light generated by the environment itself, rather than artificial sources. The material is hot enough to emit thermal radiation at visible wavelengths, though the emission is weak and shifted toward the red end of the spectrum by the temperatures involved. The darkness is no longer complete, but rather a deep red dimness that extends in all directions around your vessel. The electrical currents flowing through this metallic ocean generate Jupiter's powerful magnetic field, the largest and most powerful magnetic field of any planet in the solar system, by substantial margins. The field extends millions of kilometers into space, creating a magnetosphere that would swallow the sun if it could be made visible against the surrounding darkness of the outer solar system. The same magnetic field that deflects charged particles and creates auroras at Jupiter's poles originates here in the metallic hydrogen layer through which you are now traveling on your descent. Electric currents circulate through the conducting medium as the planet rotates, generating the field through the same dynamo process that creates Earth's magnetic field in its liquid iron core. The view through your observation ports shows the faintly glowing metallic hydrogen extending in all directions without boundary or interruption. The red dimness illuminating nothing except the substance itself. No features or structures appear visible in the uniform material surrounding your vessel, the medium continuous and unchanging in every direction you might look through your observation ports. The experience differs from the complete darkness of the molecular hydrogen layer above in subtle but meaningful ways, the presence of any natural light providing a different character to the environment. Your vessel's lights create their familiar cones of brightness in the surrounding medium. The metallic hydrogen reflecting and scattering, the beams in patterns slightly different from the molecular form. The scale of this metallic ocean challenges any attempt at comprehension through comparison to familiar bodies of water or other large-scale features you might know from Earth. The layer extends for tens of thousands of kilometers in every direction from your current position toward both the molecular hydrogen above and the core below, waiting at the center. The volume of metallic hydrogen in Jupiter exceeds the volume of Earth by factors of hundreds, an amount of this exotic material that dwarfs any other single object in the solar system, except the Sun itself. You are traveling through something vast, even by planetary standards. The journey through this single layer requiring extended time, even at continuous descent speeds. The temperature continues rising as you descend through the metallic hydrogen. The readings now showing values that approach 10,000 degrees Celsius, nearly twice the temperature of the Sun's visible surface. The heat comes from the same compression that characterizes the entire deep interior of this giant planet, gravity pressing down from above and converting that pressure into thermal energy. This thermal energy has no way to escape except through the slow processes of convection and conduction that carry it upward over geological timescales toward the cold of space. The planet's interior is hot, has been hot since formation over 4 billion years ago, and will remain hot for billions of years more as this primordial heat slowly radiates away. The pressure readings have climbed past 10 million atmospheres and continue building with each kilometer of descent through the metallic layer toward the core below. These forces exist nowhere else in the solar system, except in the cores of giant planets and in the interior of the Sun itself. Pressures that defy easy comprehension through comparison to ordinary experience. The metallic hydrogen surrounding your vessel is compressed to densities that approach those of the core itself. The material packed so tightly that the boundaries between individual atoms become somewhat academic. The hydrogen exists in a quantum state that has no parallel in everyday experience. Electrons shared across volumes rather than bound to individual nuclei. The convection that carries heat from the deep interior toward the outer regions operates throughout this metallic layer. Invisible currents of liquid metal, rising and falling in patterns you cannot perceive directly. These convective motions are driven by the temperature differences between the hot core and the cooler exterior, material rising where it is heated and sinking where it cools in patterns similar to boiling water. The timescales of this circulation span centuries or millennia rather than the moments of your passage through this region, the massive currents moving at paces too slow to detect during descent. Yet the motion is real, the metallic ocean churning slowly as it has churned since the planet formed from the primordial solar nebula. The journey through the metallic hydrogen layer continues for what feels like an extended period of travel. The depth readings accumulating thousands of kilometers of progress through this uniform medium. No visible features mark the passage. No landmarks appear to indicate progress through the vast interior. Only the steadily changing readings on your instruments, confirming that descent continues. The experience is one of traveling through something vast and featureless, the environment changing only in the gradually increasing readings of temperature and pressure that your instruments report with each passing kilometer. The core approaches somewhere below, but significant distance still separates your current position from that ultimate destination at the center of the planet. The metallic hydrogen that surrounds you represents most of Jupiter's total volume, this single layer comprising the bulk of the planet's interior by a substantial margin. Only the relatively thin atmospheric layers above and the compressed core below account for the remainder of the planet's structure, the metallic ocean dominating everything between them. The journey through this region carries you through the heart of what Jupiter actually is, not the colorful clouds visible from space that attract so much attention, not the storms and weather patterns that characterize the upper atmosphere and provide visual interest. This vast ocean of liquid metal contains most of the planet's mass and generates most of its distinctive properties. The faint red glow continues as you descend through kilometer after kilometer of metallic hydrogen. The material emitting thermal radiation at temperatures that continue climbing toward the core. The illumination provides no useful visibility for practical purposes, merely a confirmation that the material around you is hot enough to generate light through its own thermal energy without any external source. The experience of traveling through this glowing medium differs from any terrestrial parallel you might imagine. The environment simultaneously dark in practical terms and luminous in physical reality. The metallic ocean glows with heat that has been accumulating since the formation of the solar system over 4 billion years ago. The substance behaves as a unified metallic whole rather than as a collection of separate atoms, the electrons flowing freely through the material in ways that create the electrical conductivity defining this state of matter. The familiar hydrogen that fills balloons and combines with oxygen to make water has been transformed into something entirely different through nothing more than extreme pressure, the compression forcing a fundamental change in how the atoms interact with each other. This transformation occurs nowhere naturally on Earth, the pressures required exceeding anything found in our planet's interior by enormous factors. Laboratory experiments have created tiny amounts of metallic hydrogen momentarily using diamond anvils, but Jupiter maintains this state continuously across volumes larger than Earth. The descent continues through the seemingly endless metallic ocean, your vessel pushing through the dense medium toward the core that waits somewhere in the depths below your current position. The resistance to movement has grown substantially from what you experienced in the upper atmospheric layers. The liquid metal pressing back against your passage with force proportional to its increasing density. The environment around you would crush any ordinary structure and would be instantly lethal to any unprotected life. Yet, the descent proceeds smoothly through your imaginary vessel's protective capabilities. The journey carries you deeper into conditions that exist only in the hearts of giant planets, environments that theory describes, but that no physical traveler could survive. The readings continue their steady evolution as the descent proceeds, temperatures climbing past the values found at the surface of the Sun, while pressures exceed anything found naturally on any rocky planet. The environment has moved entirely beyond any earthly parallel. The numbers on your displays representing conditions that challenge intuition, developed through experience with the gentle pressures and moderate temperatures of Earth's surface. The metallic hydrogen surrounds you in its warm red glow, the ocean of liquid metal extending in all directions towards boundaries still thousands of kilometers distant in every direction. The journey through this single layer of Jupiter's interior continues toward whatever transition marks the approach to the core. The descent through the metallic hydrogen continues as your vessel travels deeper into Jupiter's vast interior. The depth readings accumulating tens of thousands of kilometers since entering this layer far above your current position. The core still remains distant below, waiting at the center of the planet, where conditions reach their most extreme values. But the approach proceeds with each passing moment of descent through the liquid metal ocean. The scale of this ocean reveals itself through the time required to cross it, the journey through the metallic region taking longer than the entire passage through the atmospheric layers above, despite the continuous, steady pace of descent. The metallic hydrogen extends around you in all directions without boundary or feature, uniform and featureless throughout its vast extent. The temperature readings have climbed past 15,000 degrees Celsius, approaching the surface temperature of some smaller stars that burn in the distant reaches of the galaxy. The heat of compression continues to build as pressure increases with depth. The weight of all the atmosphere above converting into thermal energy that has nowhere to escape except through slow convection. The environment outside your vessel has become genuinely stellar in character. Temperatures that would vaporize any ordinary material, pressures that would crush atomic structures into degenerate states. Densities approach those found in the cores of dying stars, the conditions characteristic of stellar interiors rather than planetary ones. Jupiter is not a star. It lacks the mass to sustain the nuclear fusion reactions that power stellar existence and generate stellar light across the universe. Yet its interior conditions approach stellar values in ways that demonstrate how close this planet came to becoming something else entirely when the solar system was forming. A few more Jupiter masses of hydrogen accumulated during formation might have pushed the core temperature and pressure past the threshold for sustained hydrogen fusion. The planet would have ignited into a small red dwarf star, fundamentally changing the solar system's architecture and the conditions on the worlds orbiting the Sun. The pressure readings have reached tens of millions of atmospheres, forces so extreme that the numbers cease to have intuitive meaning for anyone accustomed to the gentle pressures of Earth's surface environment. Even the modest depths of Earth's oceans produce pressures that seem enormous by everyday standards. Yet, these Jupiter interior values exceed ocean floor pressures by factors of millions. The metallic hydrogen surrounding your vessel is compressed to densities several times greater than iron would be under ordinary conditions at Earth's surface. The lightest element has been transformed by pressure into one of the densest substances in the solar system. The matter here exists in states that laboratories struggle to create even momentarily, using the most extreme pressure-generating equipment available to experimental physics. Diamond anvil cells can produce these pressures in volumes smaller than a grain of sand for fractions of a second before the diamonds themselves fail under the stress. Yet Jupiter has maintained these conditions continuously for over 4.5 billion years through nothing more than gravity, the weight of atmosphere pressing down from above, without interruption since the planet formed. The scale difference between laboratory experiments and planetary interiors spans many orders of magnitude in both size and duration. The convective motions that circulate through the metallic ocean continue operating around your descending vessel. Rising currents of hot material carrying heat from the deep interior towards the outer regions. Cooler material sinks to replace what has risen in the continuous circulation that characterizes this layer. The pattern driven by temperature differences between the hot core below and the cooler exterior above. The timescales of this circulation span centuries or millennia, the massive currents moving at paces too slow to detect during the moments of your passage through this region. The motion happens on timescales appropriate to planetary evolution rather than human observation. Yet, the motion is real, the metallic ocean churning slowly as it has churned since the planet formed from the gas and dust of the primordial solar nebula. Heat works its way outward through the patient circulation of material between hot and cold regions, energy transferring from the compressed interior toward the cold darkness of space, far above. The process will continue for billions of years as Jupiter slowly cools, releasing the primordial heat that was generated during its formation and accumulated compression. The planet is still settling, still cooling, still evolving toward an equilibrium that lies far in the future. The magnetic field generated by currents in this metallic layer reaches its strongest intensity at these depths, the electrical circulation closest to its source, creating the most powerful field lines. These field lines extend outward through the entire planet and into the surrounding magnetosphere that dominates this region of the solar system. The field exerts no perceptible force on your vessel at the scales involved in human experience. The magnetic interaction too weak to feel, despite the enormous field strength involved. Instruments detect the strength of the magnetic environment as orders of magnitude greater than anything found naturally on Earth's surface. The faint red glow of the hot metallic hydrogen continues providing the only natural illumination at these depths. The thermal emission creating a dim luminosity that extends in all directions. The glow has grown slightly brighter as temperatures have increased during the descent, though visibility remains essentially zero for practical purposes, without the artificial lights that your vessel provides. The experience is one of traveling through a universe of dim red warmth, suspended in something that glows without providing useful light for navigation or observation. Conditions that would be instantly lethal appear almost peaceful through the protective barrier of your vessel's hull. The journey through the metallic ocean continues with a rhythm established over the extended descent, the readings changing gradually rather than suddenly with each passing kilometer of progress. The temperature climbs, the pressure builds, the density increases, all the measurements moving in the directions that physics predicts, without any dramatic transitions to mark the progression. The continuous nature of this descent through continuous medium creates a meditation on gradual change, the slow transformation of conditions through patient accumulation of small differences. The environment evolves rather than transforms, changing incrementally rather than suddenly. The core region approaches somewhere below your current position, the end point of this journey through Jupiter's layered interior, where the metallic hydrogen eventually gives way to denser material. The denser material concentrates at the very center of the planet. Heavy elements that sank inward during formation, when the interior was even more fluid than today. Scientists remain uncertain about the exact nature of this core, whether it represents a distinct, solid mass of heavy elements or a diffuse region where heavy materials mix with compressed hydrogen without forming any clear boundary. The descent will reveal what awaits as you approach whatever transition marks the boundary. The density of the metallic hydrogen surrounding your vessel continues increasing with depth, the material now comparable to some of the densest naturally occurring substances on Earth, despite being composed of the lightest element on the periodic table. The compression has packed hydrogen atoms so closely together that the electrons have become a shared sea, flowing through the material rather than orbiting individual nuclei. The nuclei are embedded in this quantum fluid, like berries suspended in gelatin, the analogy failing to capture the true strangeness of this state of matter. Matter exists here in forms that have no parallel in everyday experience on Earth. The view through your observation ports remains unchanged throughout the descent through this portion of the metallic layer, the uniform medium extending in all directions without features to mark progress. The journey has become an exercise in patience. The time required to traverse this vast region, forcing an acceptance of the pace at which even rapid descent covers distance through something so enormous. The planet's scale impresses itself upon your consciousness through this experience of extended travel through uniform medium. Jupiter reveals its true nature as something far larger than clouds and storms might suggest from the outside. The readings continue their steady evolution as the descent proceeds toward the core, temperatures approaching 20,000 degrees Celsius, while pressures exceed 50 million atmospheres. Densities climb toward values that will characterize the core region below, the environment becoming progressively more extreme with each kilometer of continued descent. The conditions have moved entirely beyond any earthly parallel, existing nowhere else in the solar system, except in the deep interiors of the giant planets and the Sun itself. The journey has carried you to one of the most extreme environments accessible anywhere in our cosmic neighborhood. The transition toward the core region begins showing its first signs in the changing properties of the medium surrounding your vessel. Subtle differences appearing in instrument readings. The uniform metallic hydrogen begins to exhibit characteristics indicating heavier elements mixing with the hydrogen at increasing concentrations as you approach the boundary. The core does not begin suddenly, but rather emerges gradually from the metallic ocean. The boundary diffuse rather than sharp, the transition occurring over thousands of kilometers. The end point of this journey approaches not as a dramatic arrival, but as a gradual emergence into the final region of Jupiter's layered interior. The composition of the material surrounding your vessel begins changing as you approach the innermost regions of Jupiter's interior. The pure metallic hydrogen giving way to a mixture that includes progressively higher concentrations of heavier elements. The transition happens gradually rather than suddenly, not through any visible change in the glowing medium around you, but through the readings on instruments that detect the presence of different elements. Iron and silicon and other materials that sank toward the center during the early stages of planetary formation appear in increasing concentrations with each kilometer of descent. The core region approaches not as a distinct boundary, but as a gradual blending of compositions. The metallic hydrogen ocean mixes with denser materials in this transition zone, the composition shifting continuously from primarily hydrogen to primarily heavy elements over thousands of kilometers of vertical extent. The boundary depends on definitions rather than any sharp physical transition visible during your descent. Scientists using different criteria to mark where the core begins depending on their research focus. Some define the core as the region where heavy elements dominate over hydrogen by mass fraction, while others use different compositional or density thresholds. The experience of descending through this transition zone involves continuous change rather than any dramatic moment of arrival at a distinct boundary. The temperature readings have reached values that exceed 20,000 degrees Celsius, hotter than the visible surface of the Sun that warms the planets of the inner solar system from its position nearly 800 million kilometers away. The heat of compression continues its relentless increase as pressure builds toward the most extreme values found anywhere in this planetary interior. Gravity doing the work of heating through the compression it causes. The conditions at this depth would destroy any ordinary material almost instantaneously through a combination of pressure and temperature and density. Your imaginary vessel continues its protective function, carrying you through conditions that theory can describe, but that no physical experience could survive. The pressure has reached approximately 100 million atmospheres, forces that exceed the central pressure of Earth by factors of hundreds. Approaching the values found at the cores of the smallest stars, the metallic hydrogen at this depth has been compressed to densities that challenge the boundaries between different states of matter, the electrons forming a degenerate gas that exerts its own pressure. This electron degeneracy pressure resists further compression through quantum mechanical effects rather than thermal motion. The behavior of matter, governed by principles that emerge only under conditions this extreme. The physics at these depths involves quantum effects that have no parallel in everyday experience on Earth. The gradual mixing of heavy elements into the metallic hydrogen creates the uncertainty about exactly where the core begins. The transition zone extending across thousands of kilometers without any sharp boundary. Heavy elements concentrated at Jupiter's center include iron and nickel from the rocky materials that first began accumulating when the planet was forming from the primordial solar nebula. Silicates and perhaps water ice compressed into dense, solid forms under extreme conditions also contribute to the core composition, the materials sorted by density during the planet's early history. These materials sank toward the center when the interior was even hotter and more fluid than today's conditions allow. The settling process took hundreds of millions of years to complete, gravity gradually sorting the planet's composition by pulling heavier materials toward the center, while lighter hydrogen and helium floated toward the outer regions. The result is the layered structure you have been descending through, each layer representing different conditions that produce different states of matter from the available elements. The core represents the endpoint of this sorting process, the densest materials concentrated at the deepest point, where they have remained essentially unchanged for billions of years since the settling completed. The core represents the seed around which Jupiter grew, the original rocky body that accumulated enough mass through collisions with planetesimals to begin capturing hydrogen and helium gas from the surrounding solar nebula. The rocky core grew first, accumulating from the solid materials present in the outer solar system during the era of planetary formation, then began pulling in the vast envelope of gas that now surrounds it. Without this initial rocky seed, Jupiter might never have formed, the hydrogen and helium dispersing back into space rather than accumulating into a planet. The core you are approaching is the ancient foundation of everything above. The glow of the hot material has intensified slightly as temperatures continue climbing beyond 20,000 degrees, the thermal radiation shifting further toward visible wavelengths as conditions become increasingly extreme. The illumination remains dim by any practical standard of visibility, providing only confirmation that the surrounding medium is hot enough to generate light through its own thermal energy, rather than useful visibility for observation. The experience is one of traveling through warm darkness, surrounded by something that glows without truly illuminating, the conditions increasingly stellar in character as the center approaches. The boundary between planet and star blurs at these depths. The instruments measuring composition show the hydrogen fraction declining steadily as you continue descending toward the center, heavier elements appearing in progressively greater concentrations with each kilometer of progress. The mixture transitions gradually from hydrogen-dominated to heavy element-dominated over the thousands of kilometers of the transition zone. The boundary diffuse enough that marking its precise location requires arbitrary choices. The journey carries you through this gradual change, the environment evolving continuously rather than transforming suddenly as the core emerges from the metallic ocean. The emergence resembles a continent rising from the sea in geological slow motion. The mass above your position now includes almost the entire planet. The accumulated weight of Jupiter's atmosphere and liquid hydrogen and metallic hydrogen layers, all pressing down toward the central region. The core supports this immense load through the pressure it generates, the compressed matter resisting further compression with forces that balance the gravitational weight, trying to crush everything toward the center. The balance has been maintained since the planet formed over 4.5 billion years ago, gravity pulling inward while pressure pushes outward in a static equilibrium. The structure has remained stable across billions of years of cosmic time, while Earth evolved through ice ages and continental drift. The view through your observation ports continues showing the glowing medium that has characterized the deep interior throughout your descent, though subtle changes in color and brightness indicate the evolving composition. Heavy elements mix in increasing concentrations as you approach the core, their presence affecting the optical properties of the material in ways your instruments can detect even if your eyes cannot distinguish the differences. The experience remains one of traveling through uniform medium without visible features. The journey continuing through gradual rather than dramatic changes, even as conditions become more extreme than anywhere else accessible. The temperature readings approach 30,000 degrees Celsius. As you enter the innermost portions of the transition zone, values that exceed the surface temperatures of most stars and approach the conditions found in the sun's outer layers. The heat has no visible source, no fusion reactions occur in Jupiter's core, no nuclear fire burns at its center as it does in true stars that dot the galaxy. The warmth is simply the accumulated product of compression, energy stored since the planet's formation, when material fell inward under gravity and converted its motion into heat. This heat has been slowly escaping ever since, through the convection and conduction that carries energy outward. The density has reached values approaching those of solid iron under ordinary conditions, though the material here behaves nothing like ordinary solid iron that you might encounter on Earth's surface. The extreme pressure and temperature create states of matter that have no equivalent in everyday experience. The atoms distorted from their normal configurations by the forces pressing on them from all directions. The hydrogen that once dominated the environment has largely given way to heavier elements, the composition shifting from the lightest element to the products of stellar nucleosynthesis that were present in the solar nebula. The core material represents the ancient substance from which the planet grew. The final approach to the center carries you through the innermost portions of the core region, the gradual transition now essentially complete as the environment becomes dominated by heavy elements. The pressure reaches its maximum value, the temperature its peak, the density its greatest level, all the extremes concentrated at this central point that represents the end point of your descent. The center of Jupiter waits just below, the destination of this long journey through every layer of the largest planet in our solar system. The descent approaches its completion. The center of Jupiter surrounds you now, the end point of a descent that began at the cloud tops tens of thousands of kilometers above your current position in the compressed heart of the planet. The conditions at this depth represent the most extreme found anywhere in the planetary interior. Pressure approaching 40 million atmospheres, temperature exceeding 30,000 degrees Celsius, density several times greater than iron under ordinary conditions. The material around you consists primarily of heavy elements compressed into states that exist nowhere else naturally except in the cores of giant planets and the interiors of stars. Matter behaves here according to quantum principles that dominate at these extreme pressures. The journey has carried you from the cold vacuum of interplanetary space through every layer of Jupiter's complex structure, each layer presenting different conditions and different challenges to understanding. You descended through the upper atmosphere, where the first wisps of hydrogen marked the boundary with the emptiness of space, through the ammonia ice clouds that create the bright zones visible from outside the planet. The descent continued through the ammonium hydrosulfide layer that colors the darker belts, through the water clouds where familiar chemistry appears in an entirely alien context, far from any planetary surface. Each layer presented its own character. The descent continued through the clear atmosphere, where sunlight gradually faded from dim to absent, through the transition to supercritical hydrogen, where gas became liquid without any distinct boundary marking the change. You traveled through the vast metallic ocean that comprises most of the planet's volume, liquid metal extending for tens of thousands of kilometers in every direction around the slowly descending vessel. Now you have arrived at the center, the end point of a voyage through conditions ranging from near vacuum to millions of atmospheres, from extreme cold to stellar temperatures. The center holds you in its compressed embrace. The core region itself remains somewhat mysterious, even with your presence at its very center. The exact nature of this compressed material, difficult to characterize with the precision that scientists would prefer. The heavy elements, iron, nickel, silicates, perhaps compressed water ice, exist in states that cannot be replicated in laboratories on Earth. Their behavior under these extreme conditions, known only through theoretical calculations. No experiment can reproduce these pressures for more than fractions of seconds in volumes smaller than grains of sand. The material may be solid or liquid, or something that defies either category, the distinction becoming academic under conditions where atomic structures themselves are distorted by pressure. The temperature at the center exceeds the surface temperature of the Sun. The accumulated heat of compression, creating conditions more characteristic of stellar interiors than planetary ones by normal standards of classification. Jupiter is not a star. The nuclear fusion that powers the Sun and all the stars you can see in the night sky cannot occur here because the temperatures and pressures remain insufficient. The repulsion between atomic nuclei prevents the initiation of sustained fusion reactions that define stellar existence even at these extreme conditions. Yet, the conditions approach stellar values closely enough that the boundary between planet and star becomes a question of degree rather than fundamental kind. Jupiter is what a star looks like before it achieves the final threshold of mass required for ignition. A failed star that came close, but ultimately lacked the necessary mass to make the transition. A few more Jupiter masses of hydrogen accumulated during formation would have pushed the core past the threshold for sustained hydrogen fusion. The planet would have ignited into a small red dwarf star, joining the hundreds of billions of stars that populate our galaxy. Instead, Jupiter remains a planet, the largest in our solar system, but still fundamentally planetary in nature, generating heat through compression rather than fusion. The pressure at this central point reaches approximately 40 million atmospheres, the weight of an entire planet pressing inward from all directions toward this central region that must support the load. The compressed matter resists further compression, with forces that balance the gravitational weight, trying to crush everything toward the geometric center of the planet. The balance has been maintained since Jupiter formed over 4.5 billion years ago, gravity pulling inward while pressure pushes outward in a stable equilibrium. The structure remains stable across timescales that exceed the existence of complex life on Earth by enormous margins. The planet will continue existing in this balanced state for billions of years into the future. Gravity and pressure locked in their eternal standoff at the center, while the layers above slowly evolve through cooling and convection. The core will remain essentially unchanged as the metallic ocean above continues circulating, as the atmosphere maintains its weather patterns and storms, as the moons continue orbiting in the space far above the cloud tops. The center is the most stable part of the entire structure, the conditions here changing less over cosmic timescales than anywhere else in the planet. The glow of the core material has reached its maximum intensity. The thermal radiation emitted by matter at 30,000 degrees, creating the brightest natural illumination you have encountered since the sunlight faded in the upper atmosphere. The light remains dim by the standards of visibility you might expect from such extreme temperatures. The dense matter absorbing much of the radiation it generates before it can travel far from its source. The experience is one of warm dimness rather than brilliant light, the center of Jupiter glowing without truly illuminating its surroundings in any way useful for observation or navigation. The density of the material at this central point exceeds that of lead or gold under ordinary conditions. The heavy elements compressed so tightly that the spaces between atoms have been squeezed to their minimum possible values. The electrons form a degenerate gas that provides much of the pressure supporting the overlying weight, the quantum mechanical principle preventing electrons from occupying the same state, creating resistance to further compression. Gravity cannot overcome this quantum resistance without additional mass that would push the system past the threshold for stellar ignition. The core exists in a balance between classical gravity and quantum mechanics. The view through your observation ports shows the glowing compressed matter extending in all directions from your position at the center of the planet, the end point of the journey visible only as the medium surrounding you. No distinct feature or boundary marks the center. No sign announces this location as special, in any way visible to observation. Only the readings on instruments confirm that further descent is impossible because there is nowhere deeper to descend, the center existing as a geometric point rather than a physical landmark. You have arrived at the destination through every measure except visual confirmation of anything distinct. The mass of Jupiter distributes itself around this central point in layers that you have traversed during your long descent from the cloud tops to this compressed core. Each layer represents different conditions that produce different states of the matter they contain. Hydrogen transforming from gas to liquid to metal, to this final mixture with heavy elements. The atmospheric layers above account for only a small fraction of the total mass. Most of the planet consisting of the compressed hydrogen and helium that fills the vast volume between atmosphere and core. The core itself represents perhaps 15 Earth masses of heavy elements concentrated at this central point. The stillness at this depth exceeds anything encountered during the descent. The convective motions that circulated through the metallic hydrogen, unable to penetrate into the compressed core where material remains locked in place. The extreme density prevents the circulation that characterizes the layers above. The matter here too compressed to participate in the slow churning that transfers heat outward through the metallic ocean. The core has been essentially static since the planet finished forming. The matter here unchanged across billions of years, while the layers above continued their slow circulation and evolution toward thermal equilibrium. Time moves differently at the center of a planet. The material existing in states too compressed and dense to participate in the dynamic processes that characterize the regions above and create change over geological timescales. The core simply exists, supporting everything above through the pressure it exerts, the foundation upon which the entire planetary structure rests in gravitational equilibrium. The experience of being at Jupiter's center carries a weight appropriate to the significance of the location, the deepest point accessible within the largest planet in our solar system. Conditions here exceed anything found elsewhere in human experience, except in stellar interiors. The journey that began at the cloud tops has concluded here at the end point of a voyage through every layer of a world that contains more mass than all other planets combined. The center holds you suspended in conditions that theory can describe, but that no physical traveler could survive. The imagination alone capable of bringing you to this place. The compressed heart of the solar system's largest planet surrounds you in its warm glow, the destination of a descent that has traversed gas and liquid and metal and compressed heavy elements. The voyage through Jupiter is complete. The heart of Jupiter surrounds you in all its compressed glory, the center of the largest planet in our solar system, holding you in conditions more extreme than any other location accessible within reach of human exploration. The journey that brought you here began at the cloud tops, where colors painted the atmosphere in bands, visible across hundreds of millions of kilometers of space, the planet's face familiar to astronomers for centuries. The descent continued through layer after layer of increasingly dense and hot material, each layer presenting its own character and its own challenges to understanding. Now you rest at this central point, where all the extremes of pressure and temperature and density reach their maximum values. The conditions at this endpoint exceed the conditions at the center of any rocky planet by margins that demonstrate Jupiter's fundamentally different nature from the terrestrial worlds of the inner solar system. This world was built primarily from the lightest elements, compressed into states that approach the densities of the heaviest materials known to chemistry. Hydrogen and helium, transformed by pressure into something unrecognizable. The planet contains more mass than all other planets in the solar system combined. Over 300 Earth masses gathered into a single enormous sphere of gas and liquid and metal. That mass presses inward from all directions toward this central point you have reached. The central point supports the entire structure through nothing more than the resistance of compressed matter to further compression, pressure balancing gravity in an equilibrium maintained for billions of years. The balance has persisted since the planet formed over 4.5 billion years ago, stable and unchanging throughout the ages, while life on Earth evolved from single cells to the complex civilizations that now wonder about distant worlds. Jupiter has witnessed the entire history of life on Earth, from its position in the outer solar system, unchanging, while everything on the small rocky world, third from the Sun, has transformed beyond recognition multiple times. The planetary interior that extends around you represents most of what Jupiter actually is, the visible clouds and storms accounting for only the thinnest surface layer of something vastly larger hiding beneath. The metallic hydrogen ocean that comprises most of the planet's volume extends outward from your position at the center, tens of thousands of kilometers of liquid metal, generating the magnetic field that influences the surrounding region. The atmospheric layers above contain the weather patterns and cloud structures that create the planet's familiar appearance from the outside, the bands and storms that telescopes have observed for centuries. The core beneath supports everything through the pressure it generates. The moons of Jupiter orbit in the space far above the atmosphere, companions to the giant you have descended through on this long journey from cloud tops to core. Io, with its volcanic activity driven by tidal heating. Europa, with its ice-covered ocean that may harbor conditions suitable for life. Ganymede, the largest moon in the entire solar system. Callisto, with its ancient cratered surface, recording billions of years of impacts. These worlds receive no detailed attention during a journey focused on the planet itself, but they exist as companions to the giant, gravitationally bound to this enormous mass that dominates its region of space. The same gravity that creates the extreme pressure at the center where you now rest also holds these moons in their orbits. The fundamental force operating across scales from planetary cores to orbital mechanics. The moons orbit because Jupiter's gravity reaches outward into space. The same gravity that pulls the atmosphere downward and compresses the core to its extreme density, reaching outward to capture passing objects. The force that creates the conditions you experience at the center is the same force that organizes the entire Jovian system into the configuration astronomers observe from Earth. Gravity shapes everything from the smallest scales to the largest. The heat that warms the core will continue slowly escaping for billions of years into the future, conducted and convected upward through the layers above, until it eventually radiates away into the coldness of space. Jupiter generates more energy than it receives from the Sun. The internal heat, a remnant of formation and ongoing slow compression that has not yet finished escaping since the planet first coalesced from the solar nebula. The planet is still cooling, still settling, still slowly releasing the energy that was stored when material fell together under gravity during formation. The process will continue for longer than Earth will remain habitable by current forms of life. The journey through Jupiter's interior has revealed the planet as something far more than its visible appearance might suggest to observers watching from distant vantage points. The descent has carried you through gas and liquid and metal and compressed heavy elements, through conditions spanning almost the entire range of what planetary interiors can contain. Temperatures ranging from -145 degrees at the cloud tops to over 30,000 degrees here at the core demonstrate the variety hidden within a single planetary structure. Pressures ranging from near vacuum at the atmospheric boundary to 40 million atmospheres at the center complete the picture of extremity. The planet will continue existing in essentially its current form for billions of years into the future. The interior slowly cooling, while the exterior maintains the storms and weather patterns that have characterized it for as long as humans have watched. The Great Red Spot, will continue raging on the cloud tops, perhaps for centuries more, perhaps eventually dissipating as the conditions that maintain it gradually change over geological timescales. The bands will continue circling the planet, zones rising and belts sinking in the convective pattern that creates the distinctive banded appearance. The core will continue supporting everything from this central point. The darkness at Jupiter's center is not cold, but warm, not empty, but dense, not dead, but participating in the slow planetary processes that have been underway since formation and will continue until the distant future. The center exists as an endpoint of compression, a place where the inward pull of gravity has done everything it can do without achieving nuclear ignition to transform the planet into something fundamentally different. Jupiter is the largest thing it could have become while still remaining a planet rather than a star. The threshold of stellar ignition just slightly beyond its reach in terms of total accumulated mass. The ascent from this central point would reverse the journey if you chose to undertake it, carrying you back through the core transition zone and through the metallic hydrogen ocean that extends for such vast distances. The supercritical transition would pass again. The clear atmosphere would return visibility through non-metallic hydrogen, and light would gradually reappear as you rose toward the cloud layers far above. The water clouds and ammonium hydrosulfide and ammonia ice would each present themselves in reverse order during the ascent to the cloud tops, the structure revealing itself in reverse. Eventually, you would emerge into the space above the atmosphere, where the planet would appear as a banded sphere again. But for now, the center holds you in its compressed embrace, the endpoint of a voyage that has traversed the entire structure of the solar system's largest planet, from cloud tops to core. The experience of being at Jupiter's center carries meaning that extends beyond the physical location, representing a journey to somewhere genuinely remote, genuinely extreme, genuinely unlike anything in ordinary human experience. The imagination has carried you to a place that only physics can describe. Conditions that exist only in the interiors of giant worlds. An environment that represents one of the most alien yet accessible locations in our cosmic neighborhood, within reach of scientific understanding. The center of this ancient world continues its existence as it has existed since the planet formed, supporting everything above through the pressure generated by compressed matter resisting gravity's endless inward pull. The layers extend outward from this point toward the cold of space and the distant light of the sun that cannot penetrate to these depths, regardless of how long it shines. The planet is vast, ancient, extreme, and beautiful even in its hidden interior, where no light normally shines and no observer normally witnesses the conditions present. The journey through the giant planet is complete, the center reached, the destination achieved through descent. Rest now at the heart of Jupiter, suspended in the compressed core of the largest world we can visit in our small corner of the cosmos, the center of a planet that will endure for billions of years. The descent began at the colorful clouds and carried you through every layer until arriving at this end point, where no further descent is possible, where gravity and pressure balance in eternal equilibrium. Jupiter surrounds you in all directions, layer upon layer, extending outward toward where stars shine, and spacecraft might someday orbit in the cold darkness of the outer solar system. The journey through the giant is complete, and sleep may come while you rest at the center of something vast and ancient and enduring.